Okay, today we're going to finish up our operations with complex numbers, and the fourth part was multiplication. You can multiply complex numbers by the distributive property, and treating imaginary parts as like terms. So just like if you had 2x plus 3x, it's 5x. 2i plus 3i is 5i. And then a little reminder here, I squared is -1, just because this I equals the square root of 1. We're going to use this throughout this entire second part of the lesson. Example, multiply. Write each result in the form a plus bi. So we want the imaginary part second, the real part first. -2i distribute through the parentheses, -2i. -2i and 4, those two negatives cancel out, gives me an 8i squared. Remember, I squared is -1. So -8, reorder it, it has to look like this. We have our answer. If you have two binomials, you're going to FOIL them, just like if you had two binomials with variables in them. So first, outer, inner, last. First, outer, inner, last. Collect like terms. I squared is -1, gives us a +6. 18 plus 21i. We FOILed it. One more foiling. First, outer, inner, last. First, outer, inner, last. -18, +18. Collect those like terms and they go away. They cancel each other out. -81i squared. I squared is -1. +81 plus 4 is 85. We get a real number for that one. Powers of I. This is sort of fun. It's like little puzzles that you're trying to simplify to the smallest parts you can. The imaginary unit I can be raised to higher powers as shown. We're going to go through these. I to the first is I squared is -1. We're going to use that I squared, and every time we have a power of I greater than 2, we're going to break it up and try to get it into a power of 2, because I squared is always -1. It's very easy to simplify. So I to the third power, I squared times I squared is -1, so we get -I. I to the fourth, I squared to the second power, because 2 times 2 is 4. Step back one, I to the third is I squared times I, because 2 plus 1 is 3. 2 times 2 is 4, power of a power. Multiplying powers, you add, you multiply. Remember, we've done that. I squared is -1. -1 raised to an even power makes it a +1. We get 1. Let's take it a little bit higher. To the fifth, it's 1 plus 4 is 5. I to the fourth is I squared to the second. 2 times 2 is 4. I squared is -1. Squared, +1, gives us I. To the sixth, 2 times 3 is 6. I squared is -1. To the third, that's odd, it stays -1. To the seventh, 1 plus 6 is 7, so I break it up. 6 is 2 times 3 is 6, so I have I times I squared to the third power. -1 to the third power stays negative, so we get a -I. 8, I squared to the fourth power, 2 times 4 is 8. -1 to the fourth power, that's even, so it stays +1. So our goal is to break this up into I squared raised to a power of a power. Let's do some real examples. -6i to the 14th. We're told to simplify it. That -6 is just going to carry down to the end. I to the 14th. I need to break that down into I squared raised to a power. 2 times 7 is 14. -1 to an odd stays negative. We get +6. 63. That's an odd number, so I need to take an I out first, because 1 plus 62 is 63. This, 2 times 31 is 62. So it's -1 raised to the 31, which is an odd, so it stays -1, we get -I. 1/2 in front stays to the end. I to the 7th is I times I to the 6. 6 plus 1 is 7. I to the 6 is 2, I squared to the third power. 2 times 3 is 6. -1 to the third power, that's an odd power, so it stays -1, which is carried out here, and we have an answer. Last one. I to the 42nd. I squared raised to the 21st. 2 times 21 is 42. That's an odd number, so -1 to an odd number stays -1, and you have an answer. All right, the last example, dividing. Here's your reminder of past lessons. Expressions in simplest form cannot have square roots in the denominator. If you remember, if you ever got an answer with a square root in the denominator, you had to rationalize it. And you multiply it by the denominator over the number in the denominator in the numerator and denominator. This is 1. 3 times the square root of 5 is 3 square roots of 5. Square root of 5 times the square root of 5 is the square root of 25, which is 5. This is called rationalizing the denominator. Because the imaginary unit I represents a square root, you must rationalize any denominator that contains an imaginary unit. To do this, multiply the numerator and denominator by the complex conjugate of the denominator. The complex conjugates are, if you have a plus bi, you change that sign and make it a minus bi. The sign in front of your imaginary part has to change. Okay, we have 4 example problems here. That can't be there. We need to rationalize it. So I multiply it by the complex conjugate. This is a positive 5i, the complex conjugate's a negative 5i. And I'm going to go through every single itty bitty part here. I mean, every step is written out, and we're not going to have to do that every time. But I'll multiply by the complex conjugate in the numerator and the denominator. Distribute right here. Do your multiplication, negative 15, negative 50i squared. Remember, I squared is negative 1. Negative 1 makes that a positive 50. That trades over there. Negative 1 makes that a positive 25, and we simplify it. And we have our answer. Let's try another one. Complex conjugate, the sign in the middle, the sign in front of the imaginary part changes, and we FOIL it. First outer inner last, I squared becomes a negative 16. Collect like terms, 8. Collect like terms again, negative 8 plus 36i over 20. Simplify it, and you have an answer. Last example, complex conjugate. Okay, an easy one to distribute. I squared is negative 1, gives me a negative 8, so I rewrite it. I squared is negative 1, get a positive 1, and an answer. Last example. Complex conjugate, the sign in front of the imaginary part changes, and we FOIL it. First outer inner last, I squared is negative 1, collect like terms again. First outer inner last, I squared is negative 1, collect like terms, and write your answer. That's all we have for operations with complex numbers.